Hello, and today we're going to talk about different types of triangles. Triangles can be classified by their sides and their angles. So, first of all, let's look at how to classify them based off their angles. Why first angles? Well, because honestly, you're used to that. We've already been looking at different types of angles, so let's see how they correlate or correspond to types of triangles and naming them based off angles. Okay, so the first one we'll talk about is acute. So an acute triangle has three angles that are all acute. All three angles are acute. And if you recall from types of triangles, an acute angle means that they have a measurement less than 90 degrees. So each of these angles is less than 90 degrees. Acute triangles are the most common triangles drawn when people just draw a triangle by freehand. And they were used quite often with building back in the day. Nowadays, we use the next triangle that we're going to look at, and that is a right triangle. So an acute triangle has all angles are acute, and so therefore they're less than 90 degrees. So let's look at a right triangle now. So a right triangle is very, very common. And from its name, you probably can figure out something that it has a right angle in it. In other words, this angle has to equal 90 degrees. Okay, so one of the angles in a right triangle must be 90 degrees. Well, because of the sum of the angles in a triangle being 180, these two other angles have to be less than 90 because this one's 90, meaning that these two other angles are also acute. So a right triangle has one right angle and it has two acute angles. And that's what makes it a right triangle. There are some cool things that we get in correspondence to that for a right triangle. We have names for the sides here. So the sides, two sides that form the right angle, are called legs. Okay, and the side that is opposite of the 90 degrees is actually called the hypotenuse. Okay, so the hypotenuse turns out to be the longest side of a right triangle. Well, it has the largest angle opposite of it as well. And as you'll see, there is a relationship between the length of a side and the angle opposite of it within a triangle. And that's actually a very cool concept that we get to exploit a lot whenever trying to find different sides and different angles of a triangle. And so here we are with our right triangle. It has one right angle, it has two acute angles, it has two legs that form the right triangle, and the side that's opposite of the right angle is the hypotenuse. Okay, and that is a right triangle. Something else to note, these two angles here have to add up to be 90 because all three angles have to add up to be 180 degrees. But what do you call two angles that add up to equal 90 degrees? That's right, you call them complementary angles. So the other two angles have to be complementary, meaning they have to add to 90. Okay, and that is a right triangle. So let's look at the next way we can define triangles based off their sides, or based off their angles, and that will be, you probably guessed it correctly, an obtuse triangle. And an obtuse triangle is a triangle in which one of the angles is obtuse. In other words, it's greater than 90 degrees. And so if you have a triangle in which one of the angles is greater than 90 degrees, you have an obtuse triangle because that angle is obtuse. Well, what does that mean by the other two angles? That's right, they have to be acute. So an obtuse triangle has one obtuse angle and it has two acute angles. All right. Well, that's not too bad. That's pretty simple to understand. That's good. So that's what an obtuse triangle is going to be. Note how the side that's opposite of the obtuse angle is the largest side. Again, that's because there's a relationship between the angles and measurements in the sides that are opposite of it. The larger the angle, the larger the opposite side. Imagine it this way. If we had this angle being much smaller, the opposite side would be much smaller. And as we increase the angle, the distance between these 2 points increases as well. Okay? So that's the way that you can remember that. So that's our classifications by angles. There is going to be actually one more. And it's actually an acute triangle, but it's a special type of acute triangle that we're going to talk about here. So this is called an equal angular triangle. And an equal angular triangle has 3 acute angles that are all equal measurement. They're all equal measurement. And because the sum of the angles in a triangle has to equal 180 degrees, and all 3 of these are going to be equal, if we take 180 divided by 3, we get that each of these angles is going to be 60 degrees. So we have a triangle with 60 degrees for each angle. We have it being equal angular, and we automatically know that. Well, there are a lot of special properties that we can have with equal angular triangles as well, which we'll discuss in a moment. But that's how we can classify things based off their angles. Now, when we look at the sides, because there is a relationship between the sides of a triangle and the angles of a triangle, you actually can classify a triangle by both just knowing the angles or both just knowing the sides. And we'll see that in a moment. So let's move on then to classifying it by sides. So if we're going to classify this by sides, we'll start off with this one, scaling. This is the most common one, in my opinion, because none of the sides have to be equal. And a lot of times people think they draw them to be equal, but they don't necessarily. Maybe they get really close. But a scaling triangle just has 3 different side lengths. All right, so this side could be 3, this side could be 4, and this could be 5. This could be 2, this could be 5, and this could be 4. Okay, so these are scaling, meaning that none of the sides are the same measurements. Well, if none of the sides are the same measurements, what do you know about the angles then? That's right, none of the angles are the same measurement, so it's not equal angular. You know that automatically because the sides aren't the same, because there is a relationship between the angle measurement and the opposite sides. So for scaling, though, we could have a scaling right triangle. Actually, this one here would be a scaling right triangle. We could have an acute scaling. We could even do an obtuse one if we wanted. So say that's 18. Let's say that this is 11 and 8. Let's say that's 8. This is definitely an obtuse here because we have a much larger angle there. But in this case, we have a scaling obtuse, we have a scaling right, we have a scaling acute. All 3 are possible because none of the sides are the same, so they're all scaling. But depending on the angles inside, we can also define it by something else, by the angles. Okay, so that's scaling. Well, let's look at what happens when we begin to have sides that are equal. So when we have 2 sides that are equal, we call this an isosceles triangle. So let's say this is 4, and this is 6. This will be an isosceles triangle. So an isosceles triangle has some special properties. First of all, these 2 sides lengths are the same measurements. Well, as we've already discussed several times, if 2 measurements are the same, that means their opposite angles are going to also be the same. because there's a relationship between the sides and the angles that are opposite of it. So the angle that's opposite of these will be here. So these would have to be the same measurement. Okay. Well, that's kind of cool. So these angles here have special names. So we call these two things here base angles. And the reason for that is because they are next to the base. So the bottom part here would be the base, or the side that's not equal. All right, so that would be a base. These two sides are called legs. So the two sides that are equal in length are called legs. So we have our two legs, we have our base angles, and then the angle up top is called the vertex angle. Okay. And so for an isosceles triangle, what's really cool is that we get a very, very special property. If we draw what's called an altitude, so an altitude is a line drawn from a vertex straight down to the opposite side, forming a right angle. But if we draw that altitude, it will split our triangle into two equal or two congruent, meaning they have the same measurements in side and angle, two congruent right triangles. It will also bisect or split in two the vertex angle and the base angle. So I'm going to give you a second to hit pause and maybe copy down this information when it comes to labeling the sides and pieces of an isosceles triangle before I draw you another one. Okay, here we go. So I'm going to draw the same triangle again. I'm going to make it a little bigger though so you can see how this splits up. So here's an isosceles triangle with two sides measured equal 4, and then the base being 6. So our two legs are 4 and our base is 6. Because this is isosceles, I can draw from the vertex an altitude. So I just wanted to make sure it was completely straight when I went down. But I can draw an altitude, which again means you go from a vertex straight down to the opposite side and you form right angles. Okay. In doing so, that will actually split this base up in half. So this side will become 3, and this side would also be 3. And then that means all together it's still 6. This also splits this angle into two equal angles. So therefore, these two, because the base angles are the same, because these two angles are the same, because these two angles are the same, that means our side lengths will have to be the same there as well. So what does that tell us? Well, that tells us that this isosceles triangle, and anytime you have an isosceles triangle, if you draw the altitude from the vertex to the vertex angle to the base, you can create two congruent or equal size and measurement right triangles. And therefore, you can do all kinds of things with it. You can use the properties of right triangles to find missing sides and other things like that. And we'll see some examples of that later on. But this is a really cool property that's used a lot, especially when building, because you need to find out usually it's how tall the altitude is, or how high up an object is that has a triangle as a face. Well, if it's an isosceles triangle, which most of the time people do, because we like to have things be the same as humans. We like to look at it and say, oh, those two parts are equal. That's why you see a lot of times when people are building things or making things, they use triangles, and they use isosceles triangles, and they also use rectangles and squares and parallelograms. They use things where they see parts are equal. So here we are. This is an isosceles triangle, and this is a property of isosceles triangles. Okay, so we're almost done. So next, let's look at equilateral. So equilateral is an isosceles triangle where all three sides are equal in measurement. So equilateral, all three sides are equal in measurement. That's kind of cool, right? The Babylonians love these triangles. And a lot of people still use these when it comes to building. We move more towards using right angles because then we can see the right edge of it, using right triangles, excuse me. But a lot of times people still use equilateral throughout your house, or at least in isosceles, because it makes building easier. So remember we said that there is a relationship between side lengths and their opposite angles. Well, in this case, all three side lengths are the same. So that means all three opposite angles are also going to have to be the same. So all three of these angles are the same. Wait a minute. We had a different name for all three angles being the same. What was it again? That's right. It was equal angular. Equal angular. So, a very, very special property of a triangle, and only for triangles, is that if you have the sides the same measurement and you have the angles also the same measurement, it will automatically be equal angular and equilateral. For any other shape or you have, if you have equal sides, that does not mean it's automatically equal angular. For any other shape, if you have all equal angles, that does not mean it's all equal sides. Only for triangles is this true because there's a relationship between the sides and the angle measurements. So, but in every other, for all polygons or all closed shapes, if it's equal angular and it's equilateral, we call this regular. And so now you probably see why the Babylonians love this so much and why people generally like to draw these as much as they can, because it's just a regular triangle. That's what we actually call it in mathematics. We call it regular. I don't know who came up with that term, but it's regular. If all the sides are the same and all angles are the same, it is a regular figure. For a triangle, if it's equilateral is automatically regular because it's also equiangular. If it's equiangular, it's automatically regular because it's automatically equilateral as well. Only for triangles is this true. If you have one, then the other happens as well. Only for the triangles does this happen. If you have one, you automatically have the other as well. Okay? So what does that mean? If I tell you a triangle is equilateral, for instance, if I didn't have these sixes here, and I just said, hey, this triangle is equilateral, one of the side lengths is 6. Guess what? You know that, oh, that's 6 over there. I also know that's 6 over there. And I know each of these angles is 60 degrees. I automatically know that. How'd you know about the 60? Because it's equiangular. And as we talked about before, equiangular triangles have three angles of 60 degrees because they all have to be equal, and the sum of them has to be 180 degrees. So that's pretty cool. Now, I started this topic by saying that it's a special type of isosceles triangle. That means that it has the same property that we talked about with isosceles triangles. Meaning if we draw an altitude from a vertex to the base, then we can split it and form two equal right triangles, two congruent right triangles. That is also the case here. So it's quite cool. So it's really powerful what an equilateral, equiangular, or a regular triangle can do. So with all that being said, notice that this is also going to be an acute automatically. It's impossible to have an equilateral or equiangular or a regular triangle be anything other than acute because it has to be 60 degrees. And all of those angles are acute, meaning it's an acute triangle. With the isosceles, we could form a we could form an isosceles acute, isosceles right, and we could also form isosceles obtuse if we needed to. So that's all kind of cool that you can do that with isosceles triangles, and as long as you know that the two angles are the same, it's isosceles, and you can define it with the other angles based off if everything's acute, if one's a right and one's an obtuse. With equilateral, equiangular, regular, you automatically know it's an acute automatically. If you have a right triangle, you know it's a right triangle. It could be isosceles, it could be scaling. But as you can see, these all mix and mingle together. But if you understand the basic properties, that if you have three sides that are not of equal length, it's scaling. If you have two sides of equal length, it's isosceles. If you have three sides of equal length, it's equilateral. If you have three acute angles, it's acute. If you have one right angle, it's right. If you have one obtuse angle, it's obtuse. Then you'll be able to classify all these triangles anytime you see them and use basic principles and properties that go along with its classification. All right, well, that's types of triangles. I suggest going back and looking through this video and pausing in between them because there are some cool characteristics and you may notice some more things that you didn't see the first time looking through. So that's types of triangles, and I will see you soon.